Um, Good afternoon. This is Chaodit speaking, and it's real honor that I have a chance of being a presenter in this exciting forum of knowledge sharing. I am electrical engineer, trained as the inter-network engineer. Networking as for the communications. But then when facing practical problems of Bangkok, traffic congestions, then I also, with the mentorship from Professor Sarawit over there, then turned also my practical interest to the transport problem. And so kind of, therefore, I am the hybrid guy, okay, sitting on one side as an electrical engineer, communication engineer, and a little bit of the transport engineering that I have got a chance of helping Professor Kasem, Professor Sarawit in trying to solve some of the local problems at hand. Today, I would like to be a chef in providing some kind of basic cookbook. What if Bangkok network, we would like checklist on ingredients to build and to take advantage of exciting technologies, namely AI, IoT, or together AIoT, and digital twin. Here's the outline. So a little bit of political statement like challenge we are facing, opportunity that we may have, and some of the ingredients needed from the very, very big framework of these technologies. And at last, then working group number 3 activities, which I, right now, together with Japanese team, we are trying to achieve in our 3D Satreps collaborative project. Challenge. Here's what we see. I try very hard to look where is Bangkok in this so-called smart city. And the rank starting from Zurich, number 1, and the first page gone, second page is gone. Bangkok, somewhere over here. At least we top 100, okay, at the 90, over there. But then trying to dive a bit deeper to see what is really happening to Bangkok, top 100. Then in terms of the lowest score, unfortunately, that's what we could see. The infrastructure that could support Bangkok mobility is not really mobile at all, with the scoring that's towards the lower side, the left side. There's a good chance anyway, because we're also talking about technologies that become more and more affordable nowadays in terms of many aspects that we could enhance, including mobility. And if comparing to infrastructure, like old city with roots very long, the historical records, just like many cities that have never been ruined from the start. We developed the road structure in similar way to our pioneers in building Bangkok 200 years ago. So we still have the legacy of topological constraints and all kinds of things. As a result, the infrastructure, despite the challenge in further enhancement, but the digital world is not. It's another layer that we could do quite independently. Cookbook, checklist. Having to say that in Thai proverb, it would be เอามะพร้าวมาขายสวน which translated to among all the experts, then maybe all these checklists would be quite straightforward. But it's good to have a clear checklist of items as a practitioners. When engineers want to build the system anyway, and that would be a quick round view of what I personally have in this cookbook. I still keep myself as a human being in the loop. So in addition to notebook LM, I also am responsible and totally liable for all the contents over here. So I use LM only for stylage of the contents. I think there are steps when we're talking about how to climb up from data that we could process to information, transfer then to experiences, combine together. Then we have knowledge that becomes domain-specific wisdom. Along the steps, we have 4 ingredients as compulsory. From IoT, Internet of Things, sensors, controllers are those aforementioned things. But they must be networked together by communications. Things communicate to each other. We do only some not so interesting stuff unless we provide some logics. Logics could be from AI. Logics can also be from wisdoms after the social knowledge management that we brainstorm among the human practitioners on the field. And what if we want to test what if scenarios? It's going to be less harm, more beneficial to do in the digital twins, not the real world. But once we gain confidences, then we could try to project all those recommended strategies then from digital twins, the model, into the realities. 4 ingredients. Now, there are choices to be chosen by design. In Pali language, Bali, we call it ayatana inputs. Before we could sense of surroundings, then yes, what are those devices? Perhaps these are the stuff we use nowadays as devices. CCTVs or even radar, they're just devices that rely on electromagnetic waves. By the way, images, scene, radar, all those for electrical engineers, just the wireless electromagnetic waves that we control. Vibration could also be another thing. Microphone, used in order to sense how loud the road noises are, or even alarms that happening. Some people shouting helps. Then, if machine can learn to hear and understand, perhaps necessary alarms and alerts could be in time to save lives. Breathing in, well, like air quality. Perhaps if we have electronic nose, that could sniff the smells or pollutants, emissions, then we could do better. As a matter of fact, engineers start improving things by measuring things first, or to detect the presence by the touch, like loop detector that we have on the surface of the road. And once there's a metal big chunk of cars on top, then that change the magnetic fluctuation around when electrical signals being pumped into as a pulse. As a result, we could count whether or not there are cars, no cars in that installed location. Likewise, magnetic sensors or passive infrared detecting the presence. But we move on then to what actions can be done. Traffic signal light control, one of them. Ramp metering, the Expressway Authority of Thailand. Lane management, navigation, routing, rerouting, alarms, and alerts. All those could be control actions we could design. But all those must be communicated together in this nervous system that link things together. We have three things by design that we have to make. First, data, what format you want. And there are plenty of formats, but nowadays the practice is using JSON, JavaScript object notation, or XML, extensible markup language as a format. There are also internetworking standards that we have to agree. We would use internet protocol, just like the common internet. But on top of that, if we want to use web technology, then it's HTTP. Or more likely, then we design by using the message queue telemetry transport or MQTT. Telecom standards. Now, every 10 years, actually, we evolve from 2G, second generation, to third generation, 3G. It cost 10 years. 3G to 4G. 4G is LTE, long-term evolution. That's another 10 years. By the way, the boundary of 10 years is just 2000, 2010, 2010 to 2020. Right now, we in the middle, changing from 5G to 6G. And so we're talking about 5.5, 2026, so that 2030, then 6G comes. All those standards would allow us to build the so-called massive IoT infrastructure, where the cost of getting each sensor installed would be extremely cheap, we hope. Where one cell tower of the telecom operator with the radius of coverage 3 kilometers in town, 10 kilometers out of town, could cover not only hundreds, but thousands of devices simultaneously, where devices would be very energy efficient, with the batteries, once installed, would last for a couple of years and come as mass production pretty cheap. I'll give some example so that people probably from transport will understand better what electrical engineers when talking to you about some of these standards, like the data format, JSON format. Over here, it is just the JSON format for Well, maybe you want to sense some junction, and then you would like to detect the speed of passing vehicle in kilometers per hour, so that you will be able to use this for the traffic signal light. Now, one thing that transport engineers see for sure, this standard is readable by human beings. We design JSON so that we HIL, keep human in the loop. Don't cut the human out. One day when AI start to talk with another AI and we don't understand them, it's a problem. But JSON is designed to force human still in the loop of that information transfer. Message queue also forms a key architecture when we're trying to get the data. And it works in a very simple way, just like in Thai, we use line application and we have line group, and there'll be publishers of messages. To that line group, there'll be people who subscribing to a line group, and whenever a message being published, then that message automatically transfer to all the subscribers. So this client server paradigm communications been using a lot for the message queues, where we would like to make sure the order of transfer in accordance with the order of the message generation timestamps. In terms of AI, I think that in my little experience of practicing Bangkok transport research, I think we use 3 models. Well, I understand there would be supervised, unsupervised, semi-supervised. Over here, I show only supervised learning and semi-supervised. The supervised learning, here, we also have 2 things that we use in practice: regression model and classification model. For regression model, it is just that black box that's trying to predict things for us, to forecast, to foresee what is happening next half an hour, next 2 hours, or tomorrow. Classification works by sorting things out. The output now would not be the prediction of the continuous value, but rather categories of what might happen, abnormal or normal conditions, gridlock or no gridlock detected. Always discrete choices of outputs. But then if we want to make acting controls, then we use reinforcement learning. And I think that in academia, we use it a lot. In practice, I'm not that much sure in terms of the practical deployment right now. For engineers always ask question on how much we can trust it. That's going to work all the time. We used to have in classical control theory that if it works, engineers prove that it works, and we know exactly when it works and when exactly it will not work, and be happy with that. But in terms of the reinforcement learning, then is trying to learn and relearn from penalty or reward that is experienced with the environment over times. And sometimes we do not have the luxury of getting people into the pain before in order to allow our machine to learn. But one mistake might just kill the whole project. And so adopting this kind of learning things in the real environments are kind of careful steps that we have to do. In the brain that forms the digital twins, then brain could perform 3 services. That could be the data analytics services. That could be modeling services. You model with mathematics, the computer simulation, or the small test with the miniature of the real system, whatever. And performing the memory to memorize the raw data, process data, sanitize data that already excluded of some private information, ready to be released and shared with friends. Brain and services must run somewhere. And here, there are 3 business models that I think from talking to my colleagues that we use. Infrastructure service, platform as a service like IoT platform, and software as a service where it's like everything comes ready as a software that could be deployed. Interface also important, like human-machine interface. Could be private, like VR or AR, using the web, using mobile. Could be the public, like a billboard, dashboard. Private, public. But I think maybe stakeholders in Thailand interested more in this one, how to build a war room that allows team to collaborate and to make information enhanced action decisions. Now, this form the loops from the war room that is in need of the brain in the cloud, in need of communication stack, and the data that comes from the sensors, which in turn can be reconfigured by commands and controls at the war room. I show very, very quick activities we're trying to do at the Satreps 3D in my working group number 3. This is our team. It's a small team. From Japan is Univ Tsukuba with Professor Wada and me, as well as our postdoctoral researchers and students. One research, we're trying to think about one of the pain points of data sharing constraints in Thailand. Many organizations individually have their own data sets, a lot of them. But due to some legislation or policies, then data are not easily shared. In the machine learning, there's another framework which is called federated machine learning, where we allow the model to be trained and learned by the local data sets. And once the model has been trained, then instead of sharing raw data sets, no need. Just share the model parameters. And then we still can aggregate for the information needed to build the good enough model. For example, one of our students working on trying to see if we could make use of federated learning for emission prediction, like PM2.5 or carbon emission. Another student working on control example. This is one of the toll booths where we have got the manual as well as the automatic mode of the booth operations at the toll, collecting the toll. And we could try to develop the model that's going to simulate in the digital twin and trying to use reinforcement learning so that will be able to dynamically adjust and suggest the proportion of the lanes that should be operable in MTC or ETC over different period of time. And the last one is in the very large area where the team, Professor Wada at Tsukuba, and my student, our team, be working on the GBM, Generalized Bathtub Model. Right now, still under the phase of the model data collection and trying to validate it. Let me add just one infrastructure in 2 minutes before I could wrap up here. Because I'm from electrical engineering department, and in our department, we also building this energy microgrid at our Gilbert Square building for RE100 community. And this is the system that we are building in our place. The basic idea is just to use the energy management system with the microgrid controller that receives also the renewable power from photo solar cells, as well as Professor mentioned, the EV charging stations, and also the moving cars. We consider them as batteries. Along the way, then we build the whole thing by ourselves, by collaborating with our supplier partners for various systems, so that we could build a whole stack of from the devices, distribution network, monitoring protection, communication infrastructure, automatic control, and supervisory control and visualization. So if there's a chance, like coffee break, that you'd like to discuss more, then I'll be really happy to give more information. So I think that is it from me. And thank you so much for your patience in listening to my talk. Thank you very much.
Thank you for that, Chaodit. Since we still have a couple of minutes left, are there any questions on the floor? Okay, I will take the privilege of asking the question, Professor. What is your opinion on a future where operation center like the highway traffic operation center HPLC at the DOH, like no longer require human operator? If automated system can eventually resolve all issue entirely via remote control, do you think this will lead to significant job losses?
I think it's a good idea to have the central war room that involves the automatic workflow that helps engineers on site in order to make judgment. My apology if you would like my answer that I prefer full automation. Actually, I'm not. I'm kind of like still want to keep human in the loops, simply because I've been working in AI research for the past 30 years. I still do not trust it that much. I still think that we need human judgment and also human accountability in order to perform some mission critical task. But I do not reject the usages of these technologies. It's great under supervision of human experts.